Hi, this is Mr. Adams from Midway High School, and this is a video on redox half reactions. Once you can assign oxidation numbers, you can figure out who got oxidized, who got reduced, and once you can figure out who got oxidized and reduced, you can figure out agents, and once you can figure out those things, you can do half reactions. All we're doing in half reactions, we're simply separating the oxidation half from the reduction half. Now, if you notice over here, Ag is going from Ag plus to Ag0, okay, Ag by itself. So its number is going down. He's gaining electrons. To show gain of electrons, you put the electrons on the reactant side. So to do GER, you put the electrons on the reactant side. To show Leo oxidation, for example, in copper right here, copper solid would have oxidation state of 0 by itself, but you notice it's going to plus 2, right? So its number is going up. Okay, he's undergoing oxidation. So to show loss of electrons, you put them on the product side, as they did over here. Okay, so that's what we're going to be doing. In this topic, right, in the half reactions, mass, charge, energy must be conserved as in all balanced equations. So simply meaning that your number of atoms on both sides should be the same and your charge should be the same on both sides also. Now this right here in the bottom gave us a little confusion in terms of neutral elements, not changing the subscript, and elements, when they're part of a compound, okay, they might have a plus or negative charge. You treat it as a plus or negative charge, and then we will multiply the subscript up to the coefficient. Now, rather, it might sound kind of weird, but we're going to do an example right now. Okay. What you can do, you can pause the video. Okay, these reactions should look familiar. Okay, because they're in a previous video. Okay, assign your oxidation numbers and try to do the half reactions, and we'll see how we do. Okay, as always, we have oxygen right here, and 99% of the time, we agreed it will be minus 2. Okay, 2 times minus 2 would give us minus 4, right? And minus 4 plus what gives us 0? Okay, it'll be plus 4. Okay, now hydrogen is by itself. Okay, it will have a 0 oxidation state. Okay, and moving on to carbon monoxide, we know oxygen again is going to be minus 2, and minus 2 plus what gives you 0? That will be plus 2. Okay, and water, we have minus 2 again for oxygen. So notice minus 2, minus 2, minus 2 for oxygen right through, and here hydrogen will be plus 1. Alrighty. Now we want now to do the half reaction. So we can choose either one. Which guy got oxidized or reduced? Now normally we choose the oxidized guy first, but it's not a problem. You can do either or. Now we notice that hydrogen right here is going from 0 to plus 1, right? So we write our oxidation HR, right? Okay. HR stands for half reaction. Now we write this guy down right here. We write H2 down. Okay? Now we're separating what got oxidized from what got reduced. So notice right off the bat, we are not interested in oxygen because nothing happened to him. All right? So, and we're also not interested in carbon right now because he went from 4 to 2. His number went down. He got reduced. So we're only going to focus on the hydrogen. So on the reactant side, okay, on the reactant side, we have H2 with the oxidation state of 0, arrow going to H plus 1. Now, remember what we said, folks. This subscript right here, right, if the element has some type of charge to it, plus or minus, we will multiply the subscript up to the coefficient. So that 2 that you see here as a subscript, we multiply it up to a coefficient. Now we have H2 arrow to H plus 1. Okay, so now we have to make sure our charges are balanced because we have 2 hydrogens on both sides. We now have to make sure our charges are balanced. Now 2 times 0 gives us 0, right? And 2 times plus 1 gives us plus 1 on that side, plus 2 on that side. So we have to add a certain number of electrons onto the product side, because remember we're doing Leo, so we're showing loss of electrons, producing electrons, so they go on the product side. Now how many electrons do you think we're going to put? We will put 2 electrons. So 2 electrons go here, 2 negatives go there. So 2 negatives and 2 positives will give us 0 on the product side, and we have also 0 on this side. That's our oxidation half reaction. We're done. We move on now to the reduction half reaction. So I'm going to put RED. Okay, RED for short. Alrighty, reduction HR. Now, who got reduced? We know it's not oxygen because nothing happened to him. We know it's carbon. Okay, so carbon plus 4 got reduced. And what did he turn into? He turned into carbon plus 2. All right? Now, once again, guys, if we know we did Leo and we put the electrons on the product side, and you're doing GER, okay? You're doing GER, if you're gaining electrons, all right? We will put the electrons where? On the reactant side, okay? This side over here. Now, if we're going to plus 2 and we start at plus 4, how many electrons do we need to make both sides equal? Yes, we need 2 electrons, and you're done. You've just written the oxidation and the reduction half reactions for this equation, and that's it. There's nothing to it. Okay, moving on to the next one. All right, we have Na solid by itself, so that's going to be oxidation state of 0. We have plus 1 for the hydrogen. We have minus 2 for oxygen. We have plus 1 again for Na. We have minus 2 for the oxygen. We have plus 1 for the hydrogen. And this hydrogen over here will be 0. All right, so we're going to look at it carefully, and we'll ask ourselves who got oxidized. Now we're looking at it, we see, we're going to write down oxidation, OXID for short, HR, half reaction for short, okay? Now, who got oxidized? We notice that Na went from 0, okay, from the solid state 0 to Na plus 1. Okay, so his number went up. We know he got oxidized. Now, when we do Leo, where the electrons go? They go on the product side. Now, how many electrons do you think we're going to put on the product side, since this side is 0 and this side is plus 1? Yes, we will only put 1 electron, or simply E minus. All right, so I'm going to put E minus, and you're done. Okay, that's your oxidation half reaction done. We move on to the next guy. All right, who got reduced? If you look at oxygen, it went from -2 to -2, so we're not going to choose oxygen. We look at hydrogen, it went from plus 1 here to plus 1 there. But if you look carefully, it went from plus 1 here to 0 here. So we are interested in that part right there. We are interested in the hydrogen over here to the hydrogen over there. Okay? So what we're going to do, we're going to say our reduction half reaction is going to be, now notice we have a certain charge, right, of plus 1 on the H, right? So as before, our subscript will be multiplied up to the coefficient. We have 2 here. We have 2 already as a coefficient. So 2 times 2, there's 2 times that 2, gives us 4H plus 1, okay, arrow, okay, H2. All right, and we don't panic. We have 4 H's on this side. We have only 2 over here. So all we do, we put a 2 over there to balance the number of atoms. All right, so we're good to go up to now. We have 0 there. We have 4 times plus 1 is going to be plus 4. So we have plus 4 total on this side. We have 0, 4 times 0 on this side. So we know from experience, since we're doing GER, our electrons have to go on the reactant side. How many electrons we think we're going to put to make both sides equal? If this side is 0 and this side is plus 4, yes, we will put 4 electrons here. So 4 positives, 4 negatives give us 0. Okay, so 4 negatives, 4 positives give us 0. Okay, and 0 here also, and we're done. So this is simply how we would do this half reaction for the reduction. You may ask, can we reduce the coefficients? In this case right here, yes you can. If you leave it like this half reaction is correct. If you reduce it, it's also correct. All right, so either way, you're done. All right, folks. As always, hard work plus sacrifice equals success is a brief video on redox half reactions. Take care. Study hard.